Okay, welcome to today's class. Today we are going to be looking at circle theorem. We are going to start from Theorem 5, right? Before we go over to Theorem 5, I just want to establish some basic things. I hope you understand where we started from the angle. I think the basic, so far everything we've done points to the fact that the angle at the center is twice the angle at the circumference. Today we are going to be starting to look at two concepts. There are some concepts in circle theorem. There's something we call secant, and there's another thing we call tangent. Secant and tangent, right? These are two different things. When you have a circle and you have any straight line, let's say this is the center of the circle, you have any straight line, let's say this point is P and this point is Q, that cuts across the circle and touches 2 points in the circumference. We call this line a secant. Is that okay? When you have a straight line that cuts across a circle, touching 2 points on the circumference of the circle, we call the line a secant. Is that okay? Also, if we have a circle, we have a line that touches 2 points on the circumference without crossing the circle, we call this one a chord. Is that okay? We already know this one, we call it a chord, right? Now there's another kind of line we have. If we have a circle, let's say this is the center of the circle, we have a line that goes beside the circle and touches the circumference of the circle. Sorry, this is not a straight line. This doesn't look like a straight line, but just know I'm trying to make a straight line. If you have a straight line that goes beside the circle and touches the circle at only 1 point in circumference, only 1 point at circumference, we call this line a tangent. So far I think you can tell the difference between a secant, a chord, and a tangent. Secant touches the circumference of circle at 2 points. Chord does not go beyond the circle, just stops at the boundaries of the circle. Why tangent? Tangent touches the circle at only 1 point. Now, this is where we start our class. Having understood these three things, the secant, the chord, and the tangent, we're going to be focusing much on the tangent. Is that okay? Now, we have that the fifth theorem is that a tangent to a circle, that means when you draw a tangent to a circle, that you will find out that the radius of that circle will be perpendicular. That means the radius of a circle will only be at 90 degrees. Let's say I have a circle, this is the center. If I draw a radius of the circle, that's the distance between the center of the circle and the circumference, and I have a tangent, that passes by the circle. The point, a tangent will only meet the circle at only 1 point, right? At only 1 point. That point of contact will be at right angle. I can go on to prove this for you, right? I can go on to prove it for you. Just what you have to know is this. There cannot be any other line from the center of the circle that will meet this tangent, that will be at right angle, aside this radius. There cannot be any other radius that will be at right angle to this tangent, aside this radius, because it is impossible for a triangle to have two angles giving up to 180 degrees. Just imagine, let me just put it this way. I don't know if you understand what I'm saying, but just imagine that there's another radius that will come here and still be at right angle with the tangent. you see that you now already have 290 degrees within the triangle, which will be 118. So it can only be the radius that will be at right angle to the tangent. That means the point of contact. And even if this thing exists, there's such an angle, that means it's no longer a tangent, it's now a secant, because there cannot be any other line that will touch. There will not be any other point of contact between the circumference of the circle and the tangent. I don't know if you understand that. So what you just have to have in mind is that any radius that touches the point of intersect with the tangent will be at right angle to the tangent. Is that okay? So it says that the tangent to a circle is perpendicular to the radius drawn from the point of contact. That means this is the point of contact to be at right angle. Now, another thing, that is the fifth theorem. Don't worry, tomorrow we'll begin to solve some exercise on this. The sixth theorem is that the tangent drawn from an external point to, let me just say, two tangents drawn from an external point to a circle are of the same length. Let's say I have a circle. Let's say this is our point of origin. I have a tangent that goes this way. I also have another tangent that goes this way, right? And this is the point of, let's say this is the center of the circle. So this is the point of, this is a radius. This is also a radius, right? Now, what this theorem states that these two lines meeting at this point, that means this point of intersect, these two lines will be equal. That means, let me say P, Q, and let me call this X. What this theorem says that in such a case that PQ will be equal to PS. Is that okay? And we can still go on to prove it. Let me just draw a line that meets from the point of origin to the center of the circle. In this case, we have that this will be a right angle. Remember, from the fifth theorem, that a tangent meets with a radius at the point of contact to be 90 degrees. Also, this will also be a right angle, right? Remember, this is a single line. This will give us a right angle triangle. This will give us a right angle. Normally, if I drew this very well, you discover that this will be the hypotenuse, a single hypotenuse, because any side facing the right angle is the hypotenuse. So this will be the hypotenuse. Also, this will be hypotenuse for this. Also, we know that this is radius, and this is also radius. This is R. This is R. So we are having that. Let me call this O. We are having that QO is equal to QS. And we also know that both of them share PO. Is that okay? This shares PO and PO. And we have that this is a right angle. This is also a right angle. Meaning that angle OQP is equal to angle OSP. What does this prove to us? It proves to us that these two lines are equal, because if this is equal, this is equal, this is equal, this is 90 degrees, this is 90 degrees, that means definitely these two are also equal. Is that okay? So the sixth theorem says that the two tangents drawn from an external point to a circle are of the same length. Okay, so tomorrow we'll begin solving some exercises that has to do with this, so you understand better. Is that okay? We'll begin solving some examples that better explains this, and that will help you to understand it better.